Another aspect of the mole and all of its relationships has to do not only with Avogadro's number, but part over whole relationship. Part over whole. So this glucose molecule has 6 parts carbon, would actually mean 6 moles of carbon over the whole thing, 12 moles of hydrogen over the whole thing, glucose, and 6 moles of oxygen over the whole thing. So using that second additional definition of the mole, again conveying relationships, along with the second definition of the mole involving Avogadro's number, we can answer this question here. Calculating the number of C, H, and O atoms, so that atom should ring you a bell and tell you we're dealing with Avogadro's number, in 1.5 grams of glucose. So let's try to attack this problem. Start with what you're given. 1.5 grams of glucose, and 1.5 grams of glucose, which has a formula of C6H12O6, and we want to find carbon atoms. So let's go for carbon atoms first. Okay, so go ahead and convert that to mole. 1 mole of C6H12O6, okay, is about 180.04 grams of glucose, C6H12O6. So remember, carbon is about 12.01, hydrogen is about 1.01, oxygen is about 16.01. So this is what we're given to start out the problem. And now here's our important relationship with regards to the mole. For every 1 mole of C6H12O6, okay, I put this in the denominator because I want the units to cancel out. I actually have 6 moles of carbon. So this is a very important relationship, and it's one of our definitions, one of our 4 definitions of the mole, and that definition is the part-whole relationship. Okay, going from there, we can easily now figure out how many atoms of carbon are there using the second definition of the mole, and that is Avogadro's number. So for every 1 mole of carbon, we have 6.022 times 10 to the 23 atoms of carbon. Okay, so the crucial step to go from grams of glucose to the number of atoms of carbon in that glucose is this part-whole relationship. The second crucial step is the Avogadro's number, okay, which sort of relates the number of moles to the atoms, moles to the molecules, or moles to the ions. Now doing this, we will find that the grams of glucose cancel, the moles of glucose cancel, and the moles and moles of carbon, the atom carbon, cancel. So the number of carbon atoms here is going to be 1.50, doing this on our calculator, 1.50 grams of glucose times 6 times Avogadro's number, and we will divide that by 180.04. Units canceling out, we have in 1.5 grams of glucose, we have this many atoms. It's a big number, it's to be expected. 3.0, I'll do it in 3 sig figs, 3.01 times 10 to the 22 atoms of carbon. 3.02, 3.01 probably is more, I rounded one, maybe I shouldn't have, but 3.01 or to 3.02 atoms of carbon are there in 1.5 grams of glucose. Okay, we can do the same thing now. This time we're going to focus on how many oxygen atoms are in 1.50 grams of sugar. So it's the same line of thinking. Good first step is to always convert to moles. In this case, moles of glucose, C6H12O6. And then here we go again, that crucial step. The crucial step here is figuring out the parts of oxygen over the whole of glucose. So we have 6 moles of oxygen for every 1 mole of glucose. Okay, another important step, same definition as applied above, the part-whole relationship. And now, how many oxygen atoms? Anytime you see oxygen atoms, or the word atoms, you want to think Avogadro's number. So for every 1 mole of oxygen, we have 6.022 times 10 to the 23 atoms of oxygen. Like before, we'll cancel out our units. The grams and grams cancel, the moles and moles cancel, moles of glucose cancel with the moles of glucose, and finally the moles of oxygen cancel out with the moles of oxygen, yielding us atoms of oxygen. it's pretty much the same thing as above. The answer is going to be 3.022 or 3.01 times 10 to the 22nd atoms of oxygen. Okay? So start with what we are given, and we're given 1.5 grams of glucose. We will convert it to moles of glucose to get our grams of glucose given to us to cancel out. Again, our crucial first step is part-whole relationship. So for every 1 mole of glucose, C6H12O6, we actually have 12 moles of hydrogen. Okay, so that is our part-whole relationship. And then we know that for every 1 mole of H, we have Avogadro's number of atoms. As before, we can cancel out our units. The grams of glucose cancel, moles and moles of glucose cancel, and then finally moles of hydrogen cancel out with moles of hydrogen with this relationship. And doing that on our calculator, it actually should be double this number, 1.50 times 12 times Avogadro's number divided by 180.4. 180.04, and we're getting 6.02 times 10 to the 22nd, which is pretty much double 6.02 times 10 to the 22nd atoms of hydrogen.